When installing 277 volts metal-clad cable, also known as MC cable, the selection and use of appropriate connectors are crucial for safety and code compliance. Connectors that do not use a lock nut, but instead rely on a screw to compress the metal cladding of the MC cable, are permissible under certain conditions. These conditions are primarily dictated by the National Electrical Code, specifically sections related to bonding and grounding. Section 250.97 of the National Electrical Code addresses bonding requirements for circuits exceeding 250 volts to ground. This section mandates that the electrical continuity of metal raceways and cables with metal sheaths be ensured when they contain conductors other than service conductors. This requirement aims to provide a low impedance path for fault current, facilitating the operation of overcurrent protective devices such as circuit breakers or fuses in the event of a ground fault. The primary means of ensuring this electrical continuity are outlined in section 250.92 subsection B. This section specifies several methods for bonding, typically involving the use of threaded couplings, bonding jumpers, or other approved means. However, exception D to section 250.92 subsection B provides an allowance for the use of listed fittings that are identified for the purpose of ensuring electrical continuity. This exception is particularly relevant to the use of compression-type connectors that secure the MC cable without a traditional lock nut. For a connector to qualify under exception D, it must be listed by a recognized testing laboratory, such as Underwriters Laboratories, also known as UL, or Intertek, also known as ETL. The listing signifies that the connector has been evaluated and found to meet specific safety and performance standards. These standards typically include requirements for mechanical strength, electrical conductivity, and resistance to corrosion. The identification for the purpose aspect of the exception means that the connector must be specifically designed and labeled for use with MC cable and for providing electrical continuity. This information is usually found in the connector's packaging or product literature. When selecting connectors for 277 volts MC cable, firstly, ensure that the connector is listed by a recognized testing laboratory. Secondly, verify that the connector is specifically identified for use with MC cable and for providing electrical continuity. Thirdly, check the connector's listing information to ensure that it is suitable for the specific type and size of MC cable being used. Fourthly, install the connector according to the manufacturer's instructions. Proper installation is essential to ensure a reliable and safe connection. Fifthly, inspect the completed connection to ensure that the connector is securely fastened and that the MC cable is properly supported. Failure to adhere to these guidelines can result in several potential problems. Poor electrical continuity can increase the impedance of the ground fault path, reducing the effectiveness of overcurrent protective devices. This can increase the risk of electrical shock or fire in the event of a ground fault. Improperly installed connectors can loosen over time, leading to a loss of electrical continuity and potential safety hazards. Using connectors that are not listed or identified for the purpose can violate the National Electrical Code and increase liability in the event of an electrical incident. Several types of connectors are available for use with MC cable, including compression connectors, set screw connectors, and snap-in connectors. Compression connectors typically use a screw or other mechanism to compress the metal cladding of the MC cable, creating a secure mechanical and electrical connection. Set screw connectors use one or more set screws to grip the MC cable. Snap-in connectors use a spring-loaded mechanism to secure the MC cable. When selecting a connector type, consider the specific requirements of the application, including the size and type of MC cable, the environmental conditions, and the available space. In corrosive environments, use connectors that are made of corrosion-resistant materials such as stainless steel or aluminum. In tight spaces, use connectors that are compact and easy to install. The National Electrical Code is a comprehensive set of standards for the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect changes in technology and best practices. It is essential for electricians and other electrical professionals to stay up to date on the latest edition of the National Electrical Code to ensure that their work is safe and code compliant. In addition to Section 250.97 and 250.92 subsection B, several other sections of the National Electrical Code are relevant to the installation of MC cable and connectors. Section 330 covers the requirements for metal-clad cable, including the types of MC cable that are permitted, the allowable uses, and the installation requirements. Section 314 covers the requirements for outlet, device, pole, and junction boxes, conduit bodies, fittings, and handhole enclosures. This section includes requirements for the size and type of boxes and fittings that are permitted for use with MC cable. Section 300 covers the general requirements for wiring methods and materials. This section includes requirements for the support and protection of cables, the identification of conductors, and the grounding of electrical systems. The installation of 277 volts metal-clad cable requires careful attention to detail and adherence to the National Electrical Code. By selecting and installing appropriate connectors and following the code requirements, electrical professionals can ensure a safe and reliable electrical installation. Always refer to the latest edition of the National Electrical Code and consult with a qualified electrical inspector if there are any questions or concerns. The correct selection and installation of connectors for metal-clad cable are paramount to ensure electrical continuity and safety. When dealing with 277-volt systems, the stakes are even higher, necessitating a thorough understanding of the National Electrical Code requirements. The National Electrical Code Section 250.97 mandates that for circuits operating above 250 volts to ground, the electrical continuity of metal raceways and metal sheet cables must be maintained. This provision aims to provide a reliable path for fault currents to return to the source, thereby facilitating the rapid operation of overcurrent protection devices like circuit breakers or fuses. The primary concern is to minimize the duration and magnitude of fault currents, reducing the risk of electrical shock, fire, and equipment damage. Section 250.92 subsection B outlines several methods for ensuring electrical continuity. These methods typically involve the use of listed fittings designed to maintain a secure and continuous electrical connection between the metal components of the wiring system. However, exception D to this section allows for the use of listed fittings that are specifically identified for the purpose of providing electrical continuity, even if they deviate from the standard methods outlined in 250.92 subsection B. This exception is particularly relevant to the use of compression connectors, which rely on mechanical pressure to establish the electrical connection rather than traditional lock nuts. For a connector to be considered acceptable under exception D, it must meet several key criteria. Firstly, the connector must be listed by a recognized testing laboratory, such as Underwriters Laboratories, also known as UL, or Canadian Standards Association, also known as CSA. The listing mark indicates that the connector has been subjected to rigorous testing and evaluation to ensure that it meets applicable safety and performance standards. These standards typically address factors such as mechanical strength, electrical conductivity, corrosion resistance, and resistance to vibration. Secondly, the connector must be specifically identified for the purpose of providing electrical continuity with metal-clad cable. This identification is typically indicated on the connector's packaging product literature or directly on the connector itself. The identification signifies that the connector has been designed and tested to ensure that it can reliably maintain electrical continuity under normal operating conditions and during fault events. Thirdly, the connector's installation must comply with the manufacturer's instructions and all applicable requirements of the National Electrical Code. Proper installation is crucial to ensure that the connector provides a secure and reliable electrical connection. The installation instructions typically specify the correct tightening torque for the connector set screws or compression mechanism. Over-tightening can damage the connector or the cable, while under-tightening can result in a loose connection and loss of electrical continuity. When selecting connectors for 277 volts metal-clad cable, it is important to consider the specific characteristics of the cable and the intended application. Factors to consider include the size and type of the metal-clad cable, the environmental conditions, and the required level of mechanical protection. In corrosive environments, it is advisable to use connectors made of corrosion-resistant materials such as stainless steel or aluminum. When the metal-clad cable is exposed to vibration or mechanical stress, it is important to use connectors that are designed to withstand these forces. It is also important to ensure that the connectors are properly sized for the metal-clad cable being used. Using undersized connectors can damage the cable or result in a loose connection. Using oversized connectors can make it difficult to achieve a secure and reliable connection. In addition to selecting the correct connectors, it is also important to follow good wiring practices when installing metal-clad cable. These practices include properly supporting the cable, avoiding sharp bends, and ensuring that the cable is not subjected to excessive tension or compression. It is also important to properly ground the metal-clad cable to provide a low impedance path for fault currents to return to the source. Proper grounding helps to minimize the risk of electrical shock and equipment damage. The National Electrical Code provides detailed requirements for grounding metal-clad cable and other metal wiring systems. These requirements vary depending on the voltage of the system, the type of wiring system, and the location of the installation. It is important to consult the National Electrical Code to ensure that the grounding system is properly designed and installed. The use of listed and identified connectors is essential for ensuring electrical continuity in metal-clad cable systems. However, it is also important to follow good wiring practices and to properly ground the system. By following these guidelines, electrical professionals can help to ensure that metal-clad cable systems are safe, reliable, and code compliant. Let's delve a bit deeper into the practical aspects of selecting and installing these compression type connectors, especially in the context of 277 volt systems. The importance of the listing cannot be overstated. It's not just a matter of adhering to code, it's a matter of ensuring safety. Reputable testing laboratories put these connectors through a battery of tests that simulate real-world conditions, including exposure to extreme temperatures, corrosive environments, and mechanical stress. These tests are designed to identify potential weaknesses in the connector's design or manufacturing process, helping to prevent failures that could lead to electrical hazards. When examining a connector's listing information, pay close attention to the specific standards that the connector has been tested to. These standards may include Underwriters Laboratories 514B, which covers fittings for conduit and outlet boxes, or other relevant standards that address the specific requirements for metal-clad cable connectors. The listing information will also typically indicate the range of cable sizes that the connector is approved for. Make sure that the connector you select is compatible with the size of the metal-clad cable you are using. The identification for the purpose requirement is equally important. This means that the connector must be specifically designed and labeled for use with metal-clad cable and for providing electrical continuity. The labeling may include markings such as NC, metal-clad cable, or grounding type. The product literature should also clearly state that the connector is suitable for use in grounding applications. In addition to the listing and identification requirements, it is also important to consider the connector's construction and materials. Look for connectors that are made of high-quality materials such as copper, aluminum, or stainless steel. These materials offer excellent electrical conductivity and corrosion resistance. The connector's design should also be robust and durable, capable of withstanding the mechanical stresses that it will be subjected to in service. When installing compression-type connectors, it is essential to follow the manufacturer's instructions carefully. These instructions will typically specify the correct tightening torque for the connector set screws or compression mechanism. Using a torque wrench is highly recommended to ensure that the connector is tightened to the correct specification. Over-tightening can damage the connector or the cable, while under-tightening can result in a loose connection and loss of electrical continuity. After installing the connector, it is important to inspect it carefully to ensure that it is properly seated and that the cable is securely clamped. Check for any signs of damage to the connector or the cable. If you find any problems, replace the connector immediately. In addition to the requirements for connectors, the National Electrical Code also includes specific requirements for grounding metal-clad cable. These requirements are designed to ensure that the cable is properly grounded to provide a low impedance path for fault currents to return to the source. The grounding requirements for metal-clad cable vary depending on the voltage of the system, the type of wiring system, and the location of the installation. It is important to consult the National Electrical Code to determine the specific grounding requirements for your application. In general, metal-clad cable must be grounded at the source of the circuit and at each termination point. The grounding conductor must be sized in accordance with the National Electrical Code Table 250.122, which specifies the minimum size of equipment grounding conductors for various circuit sizes. The grounding conductor must be connected to a suitable grounding electrode, such as a ground rod, a metal water pipe, or a building steel. The grounding connection must be made in a manner that ensures a permanent and reliable electrical connection. This may involve the use of listed grounding clamps or connectors. When installing metal-clad cable in wet or damp locations, it is important to use connectors and fittings that are listed for wet locations. These connectors and fittings are designed to prevent moisture from entering the cable, which can cause corrosion and electrical failures. In addition to the technical requirements, it is also important to consider the safety aspects of working with 277-volt systems. Always de-energize the circuit before working on it. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. Be aware of the potential hazards of working with electricity, and take precautions to avoid electrical shock. The installation of 277 volts metal-clad cable requires careful attention to detail and adherence to the National Electrical Code. By selecting and installing appropriate connectors, following good wiring practices, and taking precautions to avoid electrical shock, electrical professionals can ensure a safe and reliable electrical installation. Remember to always consult the latest edition of the National Electrical Code and consult with a qualified electrical inspector if you have any questions or concerns. And don't forget, safety is paramount when working with any electrical system, especially high voltage systems like 277 volts.